So welcome to my YouTube channel, and in this video we will create a 2-bit adder, and then we will create with 2-bit adder a 4-bit adder. All the circuit is explained in this video. All the code is I will write that code and also simulate that code at the end of the video. Okay, let's start. First is our 2-bit adder. Quick introduction. So it is a 2-bit A, 2-bit B, and our 2-bit sum, and it is 1 bit of cout. So a typical adder circuit is there. Here Cin is our carry, so first we will give it a 0 carry as always, and then A and B, and then sum. Okay, let's run a simple simulation, but first you have to know that 0 0 0 1 1 0 1 1. So 0 1 2 and 3, these are the combinations. Okay, these are our binary, these are our decimal. So what will happen, let's run a simple simulation of theoretical simulation, this like 2 2, and if it is 0, then what will be answer? Here will be our answer 3, and here will be answer our 1. 1 is carry and 1 is 3 because of this binary simulation. Okay, this is a binary answer because it is only 2-bit. Okay, only it can store up till 3. Then next will be our cout. Okay, in this way. So if you convert this into decimal, then this is our 4. Okay, because it is like 1 1 plus 1, so it is 4. Okay, in decimal we can represent into 3. Let's take another example like 2 1 and 1. So then also answer will be same. This is a simple adder. Now in 4-bit adder you have to understand the connection, because connection is very important for writing a structural modeling, which I will tell you in code. So here will be 1:0 1:0, adder 1, adder 2, 4-bit adder. This is 2-bit adder, this is 2-bit adder, 2-bit 2-bit. So input will be also 2-bit 2-bit. Now input is also 2-bit 2-bit because 3 to 2 and 1 to 0. This is 2-bit, this is 2-bit. Okay, our total A is equal to our 3:0, B is also our 3:0, and sum is also our 3:0. Okay, so these are our 4-bit, and we have distributed this into our 2-bit 2-bit. Okay, and here Cin will be there. This Cin we will get our cout, and this cout will go to another Cin of a next block, and then we will go to our cout. So this we will use wire 1, any internal variable for this connection in our code. So let's move to our code. First, as always, module we will write 2-bit, and we need our A, B, Cin, sum, and cout. So let's declare its direction. Input wire A, what is A? 1:0, B 1:0, and C in 1 bit. Or output is also wire because we will use a sign, sum 2-bit, and cout in this way. But if cout, because it is the carry, then sum, and lastly our A plus B plus Cin. In this way you can write a simple code of 2-bit. I think you can understand this thing. Very simple code, just summation. Now main thing for this video is next part, that is writing a 4-bit adder using above code. Now here is 2 cases writing for this. First is same file should be used, means a same file will have this code and this code. Or second scenario is you can use different files, but If you write 2-bit here, then you have to include this using tick include. So we will follow this method, writing in same file. Okay, so let's write our code. Module. Now we are using this name 4-bit. Same thing, we will use A, B, C in, some C out, and we will give direction, not writing our wire because it is by default. So here it is 4-bit, this is our 4-bit, and our C in output. Some and carry out. Okay, let me check once. Okay. Now the logic for writing structural modeling is simple. Just you have to instantiate this module 2-bit, give it a name A1, and just as our instantiation, first is A, and you have to follow this you have to follow for instantiation, this positional mapping. As per this you have to write a code. Okay, now we are writing here. So A, which is our 1:0, as I have mentioned in our block diagram. B is also our 1:0. Okay, now C in for first block is C in. Okay, and sum is also our 1:0 for first block. The important part is our C out. So we need connection for this. Okay, so we are declaring a variable wire w1, writing with different color, so you can imagine why I have used this one, wire we have used. Okay, wire. Okay, now similar to this one, we are writing a 2-bit, again same instantiation but different instance.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
3:2 will be there, comma B 3:2. Now C in will be C out of this one. Okay, C in will be C out of this one, means our W1. This is connection, and some will have our 3:2, and lastly our C out, because it is 1 bit. So this is the connection part. Rest of the thing is not that complicated, writing of structural modeling. And lastly end module. So this is our 4-bit adder. You can write a 4-bit adder. This is simple coding. Okay, now let's write Testbench. So module TB, and wire is our output here. So output is our sum, which is our 3:0, and our C out, and range is our input. So A 3:0, B 3:0, and range our C. So in initial, begin and end, you can give multiple input like at #5. You can give A equal to 4. I am using binary here. It will, by default it will take binary, or you can give 6, whatever you want. 1 equal to 2. Okay, at #5. And again, one thing I have missed, which is in equal to 0 and equal to 1, and you can write dollar display or dollar monitor. Similar syntax. You can use these two things to see the input or output and module. Now without any delay I will show you the code. This is the code. Let me make it a little bigger. So this is our simple module and module. Similar code I have written above, and this is our summation, same thing, and this is our 2-bit and we are creating a 4-bit adder here. So this is a 4-bit adder code, and this is our TB, simple TB. I have used dollar monitor and dollar display. Dollar display I will show you. Okay, it's better to show you. So this time denotation I have used for dollar display because it will print one time, rest of the thing will print multiple times, therefore I have written dollar monitor. So 1 plus 2 is 3 and count C out is 0. 15 plus 1 is 16, and 4-bit is limited to 15, so it will be 1 0. Like after 9 it is 1 0 10, so it is in binary. After 15 it will be 16, that is 1 0. Okay, so here 2 plus 4 plus 1, it is 7. 3 plus 3 is 6, plus 1 is 7. Okay, so thank you for watching my video.
Please, Lord, give me a sign.